This is lesson 13, linear inequalities and absolute value inequalities. So what exactly is a linear inequality? Well, let's start by talking about a linear equation. A linear equation in x might be written as ax plus b equals 0, where a and b are numbers and x is your variable. So this would be a linear equation. So how would this compare with a linear inequality? A linear inequality might be written as ax plus b is less than 0. Or ax plus b is greater than 0. So basically, instead of having an equal sign like you would in an equation, you're going to have something that said either less than or greater than. Now, be also aware that you could have less than or equal to or greater than or equal to. But it's not cases where you have strictly equal to, okay? So if we're going to talk about linear inequalities, we must start by listing some properties of inequalities. Now, the first of these properties is the addition property, and this takes two forms. The first states that if a is less than b, then a plus c is less than b plus c. Now, even though this is referred to as the addition property, the second version of this addition property deals with subtraction. It says that if a is less than b, then a minus c is less than b minus c. So basically what this is saying is, if the same quantity is added to or subtracted from both sides of an inequality, the resulting inequality is equivalent to the original one. The next is the positive multiplication property. Now again, even though this is only referring to multiplication in the title, in actuality we have two versions, one involving multiplication, the other involving division. So the first version of this property states, if a is less than b and c is positive, then a times c is less than b times c. And the second version of the positive multiplication property obviously deals with division. And this step says, if a is less than b and c is positive, then a over c is less than b over c. Okay, so in this case we're dividing by c. In the first case we were multiplying by c. So these are the addition property and the positive multiplication property. Now there's one more property, and that is referred to as the negative multiplication property. Now with the negative multiplication property, things get a little bit different than what you might expect. So let's see what we're talking about here. Now the first case of the negative multiplication property states, if a is less than b and c is negative, then a times c is greater than b times c, okay? Now the key thing you've got to notice here is that initially we started off with a less than. Now we've switched that to become a greater than, okay? So if a is less than b and c is negative, then ac is greater than bc, okay? So you have to switch the sense of the inequality when c is negative. So the second version of the negative multiplication property says, again, we start out with the same, if a is less than b and c is negative, but then we go to division. Then a divided by c is greater than b divided by c. Again, you have to notice one thing here, that the sense of the inequality changes. Notice we started off with less than, and then it becomes greater than. And if we had done it just the opposite, if we had started off with if a is greater than b and c is negative, then we would have a over c is less than b over c. But whatever we start off with for the inequality, it switches whenever we either multiply or divide by a negative number. Well, now let's apply these properties in an example. So we start off with a fairly simple inequality. 3 minus 2x is less than 11. Now, when you're attempting to solve an inequality, you treat it almost as if it's going to be an equation or an equality. So the first thing we would do would be obviously to subtract 3 from both sides. So if we were to subtract 3 from both sides, we would end up with minus 2x is less than 8, because we'd be subtracting 3 from 11. All right, now what do you do here? If this was an equality, you would say minus 2x is equal to 8, divide both sides by minus 2. Well, you're going to do the same thing here. You're going to divide both sides by minus 2. But notice, you're dividing by a negative number. Therefore, we have to change the sense of the inequality. So after we divide, we're going to change the sense of the inequality, and the result's going to look like this. X is going to be greater than minus 4. So we treat it pretty much the same as you would do an equation or an equality. The only difference is if we have to divide or multiply by a negative number, then we change the sense of the inequality. Otherwise, the sense of the inequality would remain the same. All right, so now let's look at another example. And in this example, we're going to have the variable on both sides of the inequality. And let's see how we would handle that. So we start out with minus 2x minus 4 is greater than x plus 5. Well, notice I've got x on both sides of the inequality. So let's take and move the x terms over to the left side of the inequality. That means we're going to subtract x from both sides. So let's see what we get. We would now have minus 3x minus 4 is greater than 5. Okay, so again, we're going to take and add 4 to both sides here. And if we do that, we end up with minus 3x is greater than 9. And now we're going to divide by minus 3. But remember, what happens when we divide by a negative number? We're going to have to change the sense of the inequality. And our final answer then becomes x is now less than minus 3. Notice the sense of the inequality had to change because we were dividing by a negative 3. Now, if instead we had had 3x is greater than 9, where there'd be no negative 3, and divide by 3, we would get for an answer x is greater than 3. We wouldn't have to change the sense of the inequality. But since we're dividing by a negative number, we have to change the sense of the inequality. So let's look at one last example involving fractions, okay? Now, let's say we've got this inequality. X plus 3 over 4 is greater than x minus 2 over 3 plus 1/4. Notice we've got 4, 3, 4 as denominators. In this case, we have to come up with the least common denominator. In this case, the least common denominator is going to be 4 times 3, or 12. So we're going to multiply both sides of this inequality by 12 to get rid of the fractions or the denominators, okay? So that's both sides, because you got to keep the inequality the same, so you have to do it both sides. So the first one, 4 goes into 12 3 times. This would become 3x plus 9. The second one, similarly, we would eliminate the 3 and 4 as denominators, and we would come out with single fractions. Once we came out with single expressions without fractions, we can proceed just like we did with the previous examples and solve the inequality. So now let's look at solving compound inequalities. Well, what do we mean by a compound inequality? Compound inequality might look something like this. Minus 3 is less than 2x plus 1, and, now here's the key here, we're adding something, this word and, 2x plus 1 is less than 3. Okay, now, how can we change this to be a single inequality? Well, notice in both cases we got 2x plus 1, so I could rewrite this as the following. Minus 3 is less than 2x plus 1 is less than 3. Okay, so now we've got two less thans in this one statement here. So basically what we want to do is isolate the x in the middle of this expression. So the first thing I'm going to do is subtract 1. But remember, I have to subtract 1 from the left as well as the right, and of course the middle, which is going to lead us to the following. So now we have minus 4 is less than 2x is less than positive 2. All right, I want to get x by itself, isolate x. So what am I going to do in this case? In this case, I'm simply going to divide by positive 2. So I'll divide the left by positive 2, the middle by positive 2, and the right by positive 2. So now our result looks like this. Minus 2 is less than x is less than 1. Okay? We've isolated x in the middle, and we see that it's greater than negative 2 and less than 1. So, now, there's one last thing. If I were to graph this, what would it look like? Okay, so if I were to graph this, we would have a number line. Okay, and we'd have minus 2, then we'd have minus 1, then we'd have 0, then we'd have plus 1. Okay, and if it's between minus 2 and plus 1, but it can't equal minus 2 and plus 1, there's two ways of doing this. One way is that we simply show an open circle at minus 2, an open circle at plus 1, and we include everything between those 2 points, okay? Now that's the most common way, that's the way I most of the time will teach it. The only other way to do it is sometimes they'll show it as a parentheses. And it show you something like this. And this means it can equal minus 2, it cannot equal 1, but it's everything between. But my preference is to use the open circles. Now, if instead of just being less than, it was less than or equal to, if that were the case, then we would take and color in the circles, because in that case, x could equal minus 2, it also could equal 1. So that would be the way you would graph it. So that if it can equal those values, then you color in the circles. If it's just less than or greater than, then it's open circles. So now let's talk about one last thing, and that is an absolute value inequality. How do we go about solving that? Well, in order to talk about that, I'm going to go straight to an example. So here's an example. Minus 2 times the absolute value of 3x plus 5 plus 7 is greater than minus 13. Well, initially what you need to do is you need to get the absolute value portion of your inequality by itself on one side of the inequality. So in order to do this, I'm going to first subtract both sides by, hang on one second here, I'm going to subtract both sides by minus 7. So I'm going to subtract 7 from the left, subtract 7 from the right, okay? And then I'm going to divide by negative 2. But let's subtract by minus 7 and see what we get. So after we subtract negative 7 from both sides, okay, or we add negative 7 to both sides, our result is going to be minus 2, absolute value of 3x plus 5 is greater than minus 20. But notice, I'm going to have to get rid of the minus 2. So I've divided both sides by minus 2. Well, whenever I divide by a negative number, the inequality sense has to change. So our end result, after we've subtracted 7 from both sides and divided by minus 2, we get this. So now we have the absolute value by itself, absolute value of 3x plus 5. We've changed the sense of the inequality because we divided by minus 2. So that absolute value of 3x plus 5 is now less than 10. So now what do we do to proceed to get rid of that absolute value and solve for x? Well, let's look at this and see what we mean by absolute value. Basically, absolute value says that whatever's inside the absolute value could be either positive or negative. So we're saying it's less than 10. So that means if this is a positive number, it's going to be anything between 0 and 10. But what if it's a negative number? It could be anything from minus 10 to 0. So our result is going to look like this. And what we end up with is a compound inequality where we've got minus 10 is less than 3x plus 5 is less than positive 10. All right? We're going to solve this the same way we would any compound inequality. We're going to start by subtracting 5 from both sides, from all sides. So we subtract 5 from the middle, but we also have minus 5 on the left and minus 5 on the right. So now we have minus 15 is less than 3x is less than 5. Okay, and what I'm going to do at this point is once again divide both sides by 3, but in this case don't forget we're dividing by positive 3, so we don't have to change the sense of the inequality. So divide the left, the middle, and the right by positive 3, and we'll get our final answer. And we have for our final answer, minus 5 is less than x is less than 5/3. Again, if we were to graph this, we would graph it on a number line, and let's see, we would do the following. We'd have our number line like this, we'd have minus 5 here, and over here we would have 5/3. And remember, we don't have equals, so therefore it's open circle at minus 5, open circle at positive 5/3, and it's everything in between here. Okay? So that's the way we would graph it. So let's say we have something like this for absolute value. Let's say we have the absolute value of 5 minus 2x is greater than 7. How do we go about addressing this? Again, remember that what's inside the absolute value could be positive or it could be negative. Well, this is going to end up being not the compound inequality like we had before. It's going to be something a little different, and let's see what that's going to look like. So this becomes two inequalities with an or statement between them. So in this case, what's inside the absolute value, 5 minus 2x, could be less than minus 7, or it could be greater than plus 7. Okay? Now, we're going to take and solve this as two separate inequalities, and let's see what's going to happen here. So initially, what I'm going to do is I'll subtract 5 from both sides of the first inequality. And I'm going to do the same to the second inequality. And our result's going to look like this. So now our result looks like minus 2x is less than minus 12, or minus 2x is greater than plus 2. We're going to divide both inequalities by minus 2, just as we did before. Okay? But remember now, whenever we're dividing by a negative number, what do? We have to change the sense of the inequality. Okay? So that we're going to have to do in both cases. yielding our final result. So our final result is x is greater than 6 or x is less than minus 1. Again, let's look at how we would go to graph something like this. Again, we'd use our number line. Okay, x is greater than 6 means we're at 6. It can't equal 6, so we got an open circle there. And where do we go? Greater than means to the right. So it's everything to the right of 6. Now how about x is less than minus 1? Well, we're going to find minus 1 on the number line. Again, it can't equal minus 1, so it's an open circle at minus 1. If it's less than, that means it's to the left of this value, so it's everything to the left of minus 1. So these are the regions that satisfy this inequality. Okay, so once again, proceed to the worksheet, try that. Once you feel confident, move on to the mastery check quiz and see how well you've learned this lesson.